JavaScript. You've seen the chaos. Typeof null returns object, but null isn't an object. Nan doesn't equal itself. Empty arrays plus empty arrays become empty strings. This isn't random. These aren't bugs. They're consequences of how JavaScript's type system actually works at runtime. The language is lying to you, but once you understand why, everything clicks. Let's pull back the curtain. Before we go deep, look at the problem. Typeof null returns object. But null isn't an object. It's a primitive representing intentional absence. Nan triple equals nan? False. The same value doesn't equal itself. Empty array plus empty object? The string. None of this makes sense until you see what's happening under the hood. These outputs aren't mistakes. They're symptoms of JavaScript's type conversion engine working exactly as designed. Let's start at the foundation. In JavaScript, everything you work with is a value, a number, a string, an object, a function. Even undefined is a value. Every value belongs to exactly one type, and that type determines how the value behaves in memory, how it's compared, and how it converts during operations. You can't understand JavaScript's weirdness without understanding this. Types aren't labels you assign. They're runtime properties that JavaScript checks, converts, and uses every single time your code executes. This is where the confusion begins. Here's the fundamental split in JavaScript's memory model. When you create a primitive, like the number 42, and assign it to variable A, then assign it to B, you get two independent copies. Change B to 100, and A stays 42. They're separate values. But with reference types, it's different. Create an object, assign it to two variables, and both variables point to the same location in memory. Mutate the object through one variable, and the change appears in both. One object. Two references. This isn't a bug, it's how JavaScript manages memory. Primitives are copied. References are shared. JavaScript has 7 primitive types. String, for text. Number, for all numeric values, including integers, decimals, infinity, and nan. Boolean, true or false. Undefined, JavaScript's default absence. Null, intentional absence. Symbol, unique identifiers introduced in ES6. BigInt, for integers beyond number safe limit. Everything else? It's an object. Arrays, functions, dates, maps, sets, all objects under the hood. This list is exhaustive. Master these 7, and you control the foundation. Strings represent text. They're immutable. Once created, they cannot be changed. When you call a string method like to uppercase, you don't modify the original string. JavaScript creates a new string with uppercase characters and returns it. The original? Untouched. This immutability matters for performance and predictability. When you pass a string to a function, you know it can't be mutated. It's a guarantee. Typeof returns string. Simple, reliable, and the foundation of all text manipulation in JavaScript. JavaScript has one number type. No separate integers or floats, just number. It's a 64-bit floating point value, following the IEEE 754 standard. This means you get precision, but also limitations. Numbers larger than number.max_safe_integer lose accuracy. That's where BigInt comes in. But for everyday math, number handles it all. 42, 3.14, infinity, -0, and yes, nan, which is technically a number type. Typeof returns number for all of them. One type. Many edge cases. Booleans are simple. Two values, true and false. Typeof returns Boolean. Clean and straightforward. But here's the trap. JavaScript converts values to Booleans automatically in conditional contexts. An if statement doesn't require a Boolean. It accepts any value and coerces it. This is where truthy and falsy come in. Most values are truthy. Only a handful are falsy. Understanding this conversion is critical because it happens silently, constantly, and can cause subtle bugs. Undefined means a variable has been declared but not assigned a value. It's JavaScript's default. Declare a variable without initializing it. You get undefined. Access an object property that doesn't exist? Undefined. Call a function without returning a value? The return is undefined. It's automatic. JavaScript fills the absence with this primitive. Typeof returns undefined. It's not an error. It's a signal that something hasn't been set yet. Absence by omission. This confuses everyone. Null and undefined both represent nothing, but they mean different things. Undefined is JavaScript's default absence. You didn't set a value, so JavaScript gives you undefined. Null is intentional absence. You explicitly set a variable to null to say this has no value right now, and I mean it. It's the difference between forgetting to answer a question and explicitly saying no answer. Here's the kicker. Typeof null returns object. This is a bug from JavaScript's first implementation, and it's never been fixed because it would break the web. Use null when you want to signal emptiness. You'll get undefined whether you want it or not. Symbol and BigInt are newer primitives. Symbols are unique identifiers. Every call to symbol returns a completely unique value, even if you pass the same description. They're used for object property keys that won't collide with other properties. Useful for metaprogramming and avoiding naming conflicts. BigInt represents integers of arbitrary size, beyond number's safe limit of 2 to the 53rd. You create them with the n suffix or the BigInt constructor. Typeof returns symbol and BigInt respectively. They solve specific problems. Most code doesn't need them, but when you do, nothing else works. Everything that's not a primitive is an object. Plain objects. Arrays. Functions. Dates. Maps. Sets. Regular expressions. Even errors. They all share one behavior. They're reference types. When you assign an object to a variable, you're not storing the object itself. You're storing a reference to it in memory. This changes everything about how they're compared, copied, and mutated. Typeof returns object for most of these, except functions, which return function. But don't be fooled. Functions are objects too. They just get special treatment. Let's see the danger. Create an object user with a name property set to Alice. Assign user to a new variable called admin. Both variables now point to the same object in memory. Change admin.name to Bob, and user.name is also Bob. You didn't copy the object, you copied the reference. This is how JavaScript handles all reference types. Arrays, functions, dates, they all behave this way. Want an independent copy? You have to clone it explicitly, using spread syntax, object.assign, or a deep clone utility. Otherwise, mutations propagate across all references. One object. Multiple identities. Typeof is JavaScript's built-in type checker. It returns a string describing the value's type. Typeof hello returns string. Typeof 42 returns number. Typeof true returns Boolean. Simple enough. But typeof has quirks. Typeof null returns object, a famous bug. Typeof an array? Object, because arrays are objects. Typeof a function? Function, even though functions are objects too. Typeof is useful for primitives, but for reference types, you need different tools. Array. Is array checks for arrays. Instanceif checks constructor chains. Typeof is the first tool you reach for, but not the only one you need. Why does typeof null return object? It's a bug from 1995. In JavaScript's first implementation, values were stored with type tags in the low bits. Objects had a tag of 0. Null was represented as a null pointer, all zeros. So when typeof checked the tag, it saw 0 and returned object. Brendan Eich, JavaScript's creator, has called it a mistake. But fixing it would break millions of websites that rely on this behavior, intentionally or not. So it stays forever. A historical artifact hard-coded into the language. When you see typeof null, you're seeing JavaScript's original sin. Nan stands for not a number. But here's the absurdity. Typeof nan returns number. Yes, not a number is a number. It represents the result of an invalid mathematical operation, like dividing 0 by 0 or parsing hello as a number. The real insanity? Nan doesn't equal itself. Nan triple equals nan is false. It's the only value in JavaScript that isn't equal to itself. Why? IEEE 754 spec. Every nan is considered unique, so equality checks fail by design. This breaks intuition, but it's intentional. Nan is a signal that something went wrong. It propagates through calculations, poisoning results until you handle it. How do you check for nan? Not with equality. That always returns false. JavaScript provides two functions, isNaN and number.isNaN. They're different. IsNaN coerces the value to a number first, then checks. So isNaN, hello, returns true, because hello converts to nan. Number.isNaN doesn't coerce. It only returns true if the value is actually nan. No conversion. No surprises. Which should you use? Number.isNaN, always. It's precise, predictable, and doesn't perform hidden type conversions. IsNaN is a relic from early JavaScript. Avoid it. Now we enter the danger zone, type conversion. JavaScript converts types automatically. This is called coercion. It happens constantly. During arithmetic, concatenation, comparisons, conditionals. You don't ask for it. JavaScript decides when and how to convert based on the operation. Sometimes it's helpful, like converting the string 5 to the number 5 during multiplication. Sometimes it's chaos, like empty array plus empty object becoming. Understanding coercion isn't optional. It's the difference between writing predictable code and debugging type-related bugs for hours. String conversion happens during concatenation with the plus operator. When one operand is a string, JavaScript converts everything to a string. Number 5 plus string 10? The string 510, not 15. The number converts to a string, then both concatenate. Objects convert by calling their toString method. Arrays join their elements. Plain objects become. This is why empty array plus empty array gives you an empty string. Both convert to, then concatenate. It's predictable once you know the rule. Plus with a string always returns a string. Expect text, not math. Numeric conversion happens during arithmetic operations, except plus, which does string concatenation. The string 5 minus the string 2? The number 3. Both strings convert to numbers, then subtract. The string hello times 2? Nan, because hello can't convert to a valid number. Empty string converts to 0. True converts to 1. False to 0. Null to 0. Undefined to nan. Arrays convert by stringifying first, then parsing. So the array containing 5 becomes the number 5, but an array with multiple elements becomes nan. These rules are consistent, but you need to memorize them or use explicit conversion with number. Boolean conversion happens in conditional contexts, if statements, while loops, ternary operators, logical operators like and or. JavaScript doesn't require a Boolean. It accepts any value and converts it. 6 values are falsy: false, 0, empty string, null, undefined, and nan. Everything else is truthy. Empty arrays? Truthy. Empty objects? Truthy. The string false? Truthy, because it's a non-empty string. This surprises developers constantly. And if statement checking an empty array will execute, because the array itself is truthy, even though it contains nothing. Know the 6 falsy values. Everything else evaluates to true. Let's visualize the Boolean conversion gateway. When JavaScript evaluates a condition, it passes the value through this mental checkpoint. Is it false, 0, empty string, null, undefined, or nan? Then it's falsy. The condition fails. Is it anything else? Then it's truthy. The condition succeeds. This happens automatically. You can't disable it. Empty array passes through as truthy. The number 1 passes through as truthy. Even the string 0 is truthy, because it's a non-empty string. The only way to avoid surprises is to know the 6 falsy values by heart. Everything else converts to true. Let's see coercion in the wild. Empty array plus empty array? Empty string. Because both arrays convert to empty strings, then concatenate. Empty array plus empty object? The string, the objects to string output. True plus true? The number 2. Both booleans convert to 1, then add. The string 5 minus true? The number 4. 5 becomes 5, true becomes 1, then subtract. This isn't random. Every operation follows JavaScript's conversion rules. But without knowing those rules, the results look like magic or madness. Coercion is deterministic. Learn the patterns, and you predict the chaos. JavaScript has 2 equality operators. Triple equals, strict equality, checks type and value without conversion. The number 5 triple equals the string 5? False. Different types. No coercion. Double equals, loose equality, performs type conversion before comparing. 5 double equals 5? True. JavaScript converts the string to a number, then compares. This makes double equals unpredictable. Null double equals undefined? True. 0 double equals false? True. Empty string double equals false? True. These conversions follow rules, but they're complex and error-prone. Best practice? Use triple equals always. Explicit is better than implicit. Avoid double equals unless you absolutely need its coercion behavior. How do you avoid type bugs? First, use strict equality, triple equals, always. No implicit conversions. Second, validate types explicitly with typeof, array.isArray, and number.isNaN. Don't rely on coercion to guess your intent. Third, convert types manually when you need to, number for numeric conversion, string for strings, Boolean for booleans. Make your intent clear. Fourth, enable strict mode with use strict at the top of your files. It catches common mistakes like assigning to undeclared variables. Fifth, use a linter like ESLint with type-aware rules. It warns you before coercion surprises you. Write defensive code. Assume nothing. Here's your mental model. Every JavaScript value is either a primitive, copied by value, or an object, copied by reference. Primitives are immutable. Objects are mutable. Typeof tells you the type, but it has quirks. Null is object, arrays are object, nan is number. Equality with triple equals is strict. Double equals coerces. Coercion happens during operations. Strings for concatenation, numbers for arithmetic, booleans for conditionals. 6 values are falsy. Everything else is truthy. These aren't exceptions or bugs. They're the rules. Internalize them, and JavaScript becomes predictable. Ignore them, and you'll chase phantom bugs forever. This is the runtime reality. This is how JavaScript actually works. You started with confusion. Typeof null returning object. Nan not equaling itself. Coercion turning arrays into strings and strings into numbers. Now you understand it all. Primitives, references, coercion, type quirks, falsy values, strict equality. You have the mental model. 3 down, more to come. Next episode, we go deep on variables. Var hoisting, let and const scoping, temporal dead zones, and why the choice of declaration keyword changes the behavior of your code. Understanding variables is understanding JavaScript's execution model. See you there.